In this video, we will discuss about 1.1 integration of a function, the relation between integration and differentiation. So, as we all know, integration can also be called as anti-derivative process, or sometimes we call it as anti-differentiation process. Why Why we do call it as an antiderivative or anti-differentiation? Because basically integration is the reverse process of differentiation. For example, let's say if I want to differentiate any equation, let's say I call as Q x of equation, and then we get P of x as our answer. So straight away, the reverse process of it, which is integration, so integral of P x dx, we will decide as Q x plus C. Senang cerita, kalau awak differentiate soalan tu dapat jawapan, then if we integrate back the answer, we get the original question. Contoh, kalau saya buat satu equation, we want to differentiate, for example, x cos x. So, from previous semester, you already know if we want to differentiate this equation, you have to use product rule. And we will get cos x minus x sin x as our answer. So, the reverse process of this means if we want to integrate cos x minus x sin x with respect to x, so dx, even though you don't know the process, straight away you would know that our answer would be x cosine of x plus c. And that is basically the relation. So whenever you differentiate the question and then you get an equation for the answer, so once we integrate back the answer, we will get the original question as our final integral equation. So now we have an extra plus C in our final answer, and where that they came from. So that's for number 3. Kita discuss sikit macam mana C tu boleh muncul. Okay, so saya start dengan proses differentiation first. Let's say if I want to differentiate x squared. Semua orang tahu derivative of it will be 2x. Okay, next, let's say I want to differentiate x squared plus 5. So here, our answer is still 2x. So another example, let's say I want to differentiate x squared minus 10. Now I chose a negative constant. Our answer here is still 2x. So from here, you can see that even though we differentiate 3 different functions, we still get the same answer. And that's where C come from. So the reverse process of this means that if we want to integrate 2x dx, our answer would be the original function in this case, which is x squared. But now, from original question, we have 3 different constants. So that constant can be represented as plus C, where C in the first case is 0. In the second case, C can be positive 5. In the third case, C can be negative 10. So C kat sini melambangkan any constant from our original equation that we differentiate. Sebab tu, for final package, whenever we integrate any given function, we must put plus C at the back. So, kalau tak ada nilai, maksudnya C akan jadi nilai kosong. Kalau ada nilai, C will represent that constant value. So, that's all for relationship between differentiation and integration.